What will you show me?
Well, we look at our lab when we do the inverter testing and the arc fault detection testing.
Where's your lab?
Just over there, please follow me.
Yeah.
So you see the arc is there standing, it's not extinguished. And it will continue to burn until the sun sets or until we close the contacts. So this graph shows us for the three tests, so low current, high current, high voltage, how quickly or how much energy was actually remaining in the arc when the arc fault detection was up and running.
I see here red and blue, so Huawei and SMA, they seem to have good results.
The standard requires us an energy of a maximum of 750 joules, and we see also the SolarEdge inverter is well below 200 joules. What we see is that Huawei and SMA, they have least energy in their arc, but also here we see that the higher the current, the higher the voltage, the more energy is remaining in the arc. SolarEdge has quite a different concept. That explains also why they have more energy in their arcs. And for the SolarEdge concept with our testing facilities, it was not possible to perform test C, therefore we can't see any lines for the SolarEdge inverter. It depends. So certain systems, they have so-called optimizers, where the optimizer is a DC-DC converter distributed in the field. And with those systems, for example, the Huawei system, it is actually possible to localize the place where the arc happened. With other systems, like SMA, but also SolarEdge, this function is not available. There, we only know there is an arc, but we don't know exactly where it is.